Hello everyone and welcome to the MIDAS API webinar, Spreadsheets to Structures, PAC Bridge Automation using Excel VBA. I am Rohit Joseph, Structural Engineer at MIDAS. I have been with the company for the past 3.5 years, and prior to that I worked as a structural engineer specializing in buildings and bridges. In today's session, I'll be demonstrating the interoperability between MIDAS Civil NX and Excel VBA, showcasing how the latest MIDAS API functionalities can be leveraged to model PAC bridges efficiently. Moving on, here's a brief agenda for today's session. We'll begin by discussing what exactly an API is, why is it useful in structural engineering workflows. Then I'll introduce a few custom-made plugins developed at our end. The first one is PAC Box Girder template, a classic example of customizing model generation wizards for faster and more efficient modeling. Then we have the debonding made easy, which streamlines the workflow for modifying the debonding length of the tendons. Then we have the tendon profile plugin, which helps you to easily define the tendon profile points from Excel. It reads the Excel and then you can generate the tendon profiles much easier. Then we have the automatic PY curve plugin, which helps you with the substructure modeling. Yeah, then we have the PAC beam optimization, a practical example of design automation for pre-stressed concrete beams. Then we have the PAC composite template. Is it really necessary for you to know coding? That's what I wanted to convey in this segment. Then we have the M connector. So it's like an Excel add-in that helps automate report generation seamlessly. Then we'll discuss two of the tailor-made plugins for Hong Kong region. The one is wind and the temperature. We also have one for the load combinations as well. At the end, we'll conclude the session with API Sky is the Limit segment where you can post your API related queries in the chat box. And if time permits, we'll also have a Q&A session. Please note that I won't be explaining the code during this webinar. However, feel free to reach out afterward if you like access to the scripts or if you need tailoring them for your specific requirements. So, synergy beyond MIDAS, the concept of data transfer using API. So, API, application programming interface, allows different software applications to communicate and share data using common formats like JSON. For example, many engineers use Excel spreadsheets for design alongside MIDAS Civil Linux. Normally, this means manually copying the analysis results into spreadsheets, a time-consuming and error-prone process. But what if you could link your design spreadsheets directly with MIDAS Civil, automating the workflow, reducing manual efforts, and thus errors? So that is the whole point of API. So here you can see that onto the left, you can see a lot of platforms where you can enter the data. So one such platform is Grasshopper or Ribbit or even any kind of platform. You can see Excel spreadsheets as well. So in Excel spreadsheets, you are let's take the case of Excel spreadsheets. You are inputting everything in Excel, the material properties, all these data, material properties, section properties, the alignment, all those things are inputted in Excel. And using API, we can the MIDAS Civil NX can read all the data inside the spreadsheet and create the model for you. Okay. Likewise, even from AutoCAD, it is possible. If you have a drawing and from this drawing, it can read the data and create the model or even update it according to your requirements. Then the next part comes, designing. Yeah, so currently, as I mentioned previously, so you will be taking out the data or the analysis results, you will be copying it in your Excel spreadsheets, and then you'll be doing the design part. So what if you can directly link that with your Civil NX model? Okay, so that's basically API and how it's going to help you. Now, so again, why perform repetitive tasks? That's something that, I just gave you a brief in the previous session. So as we all know, structural consultants, we use various softwares for different purposes. So, and the construction industry is also highly fragmented. Each part of the construction process is handled by different firms using corresponding software solutions, which have minimal to zero interoperability with each other. For example, design firms, typically they use spreadsheets, as I mentioned previously. They use it for load calculations and MIDAS Civil or any other analysis application for analysis. CAD packages like MIDAS CAD for drawing generation. Then we have the construction firms that they use these constructions to manufacture the segments. Okay, each of these processes is interdependent on the other. As change in one request the entire work to be redone or reworked, completely. Thus, most of the time is spent on reworking. Okay, once the work is done, the report generation as per the DOT standards or BD standards specification again takes up another chunk of engineers' time, since it is impossible for any software to include the report format for each client. So summing up, there are three main problems engineers need help with the most. The first one is lack of interoperability between software solutions, report generation, and repetitive work. So introduction of API in the process can quickly resolve these problems. Let's move on to the custom-made plugins. The first one is the PSC box Girder bridge template. So we have excellent wizards in MIDAS. Okay. So how about, but even, after creating the models, we'll have to make some changes to your, the model file so that it's satisfies your project requirements. Okay. So why not we create our own wizards? Now, let us check out the FSM box girder bridge template. So using this template, the users can create box girder bridges using the full staging construction methodology. This was created by our colleagues in Korea. So as you can see here, you can see the base URL and the mapping key. So this is where you put the server. This is where you put the mapping key for linking the template with the model. So if you can see the apps, API settings, so the mapping key you will get it from here, and the server or the base URL you will find it over here. Okay, and it's already connected. Now, if you see that this is the new model. Okay, I have not defined anything yet. Now going on to the template, you can see that setting the units, structure type, materials, deck sections. So everything is controlled from a single Excel template. You can create your own templates according to your workflow, satisfying your needs, project specific needs. And this is again going to help if there is a new engineer or a junior engineer which is new to MIDAS or new to the organization who doesn't know much about your workflow or your style. They can directly use these templates, just input the values and control everything from from the template. You don't have to move into MIDAS, creating everything, including the revisions. So that was the whole purpose of this template. Okay, so as you can see here, so the units, you can set up the units here, Newton, kilonewton meters, and even the structure type, the 3D, all those options can be done. Now scrolling down, you will find the material properties. Okay, the concrete material property. So here the user just have to select, and you can just choose whichever grade of concrete you are looking for. Likewise for the pre-stressing steel as well. Now, now you can come down, you will see the deck sections. So in this particular template, I have given three sections. One is for the end section, and one is for the mid section, and the other one is for the diaphragm sections. So you can input all your values here. You don't have to go inside the software and create one section. Each section one by one inputting all these values. You don't have to do that anymore. You can control everything from the spreadsheets. Now scrolling down, you can see the pier sections. Then you can even set up the alignments, the deck alignments. As you can see here, for the pier, where to place the pier and what is the depth of the pier, what is the section, and like what is the range of taperness that we have to provide. So all those things can be controlled from here. And again, yeah, this is about the deck alignment. So I'm just choosing straight for now. Okay, we can go for arc as well according to this template. Scrolling down, you are going to find, how the bearings should be placed. Okay, so distance between the bearings A and B, so automatically the bearings, the rigid links, all those things will be sorted out by the template. Here I'm going to give the span arrangement. I'm saying that I need 4 spans. Okay, everything 40 meters each. Okay, now scrolling down, this is again the segment data. So these are the nodes, the elements. So according to each element, what is the section, what is the length, and what are the bearing types that we have to provide, the groups. Okay, the structure groups. So this is for the first span 1, span 2, span 3, and span 4. Now again, scrolling down, you'll find the substructure layout. So here you can define the stiffness values as well, and also where you're placing each pier and what is the height of different piers. So 8 meter, 10 meter, 12 meter, something like that. Scrolling down, this is where you control the tendon profiles. So previously you had to go inside, create tendon profiles one by one. So you can even control those from here. Okay. Now again, this is the loads, self-aid, waterproofing. So you can add all these loads here. And you can create these templates according to your workflow. You don't have to, use whatever we are giving here. So previously we used to have the wizards. Even now we do have the wizards, but after the wizard creates the model, the engineers have to make some changes to it according to their workflow. So rather than that, and revisions using the wizard was also not possible. That was the initial limitation. So again, scrolling down, now you can provide everything from a single sheet. This is the traffic loads. All those things can be done. Now, when you just click on create model, you can see that the entire data is being sent from the spreadsheet to the MIDAS Civil and X model. Automatically, it is getting created. Okay. Yes. So once the model is generated, we get a message like this. So I'll just click on OK. So now you can see the entire model has been generated. It's a straight bridge if you see from top, and you can see the construction stages are also defined. Okay, the section, the material properties, everything is all these data are directly taken from the spreadsheets. So we can see the properties, the material properties, C50 by 60, which was already defined, the tendon material properties, the time dependent material properties, okay, everything linked accordingly, and even the rigid links. So if you just click on display, automatically the rigid links are also generated, and even the springs are also provided. Okay, which was not possible, initially. Like if you have certain type of bridge and you wanted to model using the wizard. So initially the wizard used to cater for almost everything, but in between, if you have to make some changes or updating the model, it becomes a bit difficult. Okay, you cannot use the same wizard again. So you'll have to create a different model. So using this template, we can, generate everything from, you can even do the revising part as well. So assume you want to change the alignment. So I'll just scroll up and yes, here you can see the alignment part. So I'm just going to click here. I'll make it arc and I'll give a radius of minus 200. Okay, so this is how now the new alignment looks like. Okay, now if I just click on modify alignment, you can see that the alignment has been changed. Click on OK. Now, if you go to the top view, you can see that the alignment has been changed according to the alignment which was provided in the sheets. So this is how you can make changes to your existing model file. You can create your own templates and, according to your workflow, save a lot of time. So that's the whole point of this. Now, the next one is debonding made easy. So, in most of the European countries, there are a lot of standard pre-stressing sections, and often engineers have to provide various debonding lengths to the strands to satisfy the stress limits. While Midas is capable of providing debonding lengths to the pretension strands, we have a feedback about the process that it is a bit tedious and could there be any simpler way to do it. So that is when we decided to take the advantage of API and create an interactive GUI within Excel, and that is not easy to use, but also not just easy to use but also convenient when providing debonding tables in final contracting drawings. So with the help of VBA, we were able to map the tendon locations in such a way that it aligns with the actual position of the tendon in the section, and the same table can be copied and pasted into the final drawing sections. So let's see how it works. So yeah, I've taken just two models, two beams, and I'm taking the element number 17 just for extracting the data inside the element. So in the element number I'm taking 17. So when I click on get tendon data, so automatically you can see this is how the tendons are present there. Each of the tendons you can see, and we have around 48 tendons. Okay, now even while opening each one, you can see that there is no debonding length, and corresponding debonding length is provided at the bottom. Now you want to change the debonding length, just input the values here and click on update debonding length. So now you don't have to do anything. When you go inside, you can see that the debonding length has been changed. So it makes much easier for the engineers. You don't have to go inside every time for changing the debonding length values. So that is going to help you, especially when we have a lot of tendons, like more than 50 60 tendons inside a single section. So it becomes very tedious to go inside each one of it and change it, especially since it is a trial and error process. Okay. Now, tendon profile plugin, again, the main purpose of the plugin is quick tendon profile assignment. The current practice involves a lot of manual efforts. For example, most of us, we have the tendons in Excel format, or first we'll draw everything in AutoCAD, and then we take the profile points to Excel. So from Excel, we'll have to copy and do make each tendon one by one. So if it is a post tension, if you have a curvature, if the tendon is changing in plan as well, it becomes very tedious and we'll have to create one by one. Like if we have the MCT command files, yes, definitely we can do it. But again, using the MCT command file was also a bit tedious. Okay, so we thought we'll just optimize it, or make the process a bit more convenient. We have created a sample file. So this is like tendon profile using API. We can even create plugins that directly reads from the spreadsheet. So this is base URL mapping key. We just connect everything. So this is where you provide it. And we have used a bit of Python in the backend for a coding purpose, because Python is much easier to use when compared to Excel. So if you are comfortable with Python, you can directly use it for connecting your spreadsheets with the code. Uh, so this is again, you can use spreadsheet as a GUI, and you can use Python in the backend. Okay. Now you can provide the name, the curve, everything in spreadsheet format. So here, basically, we are just taking some tendons. XY coordinates remain same. Z values changes. So we want to create a couple of tendons. We can even create, as I mentioned previously, we can create a tendon profile plugin that reads from each of the cells inside the tendon, or even from AutoCAD as well. That is also possible. Just by clicking create, you can see that the tendons are already defined here. Yeah, so we get this code. We can even take this part out. Okay, so you can get a message here. So now you can see all the tendons are defined here. So likewise, we can go for the other side as well. This is on the one side. Okay. Yeah. Likewise, we can make it onto the left side. Again, we can change the values as well, the y coordinates. That will be much easier workflows that you can create from your own end. This is just a sample. When you click on OK, again you will get the message from the Python. If you don't want this, we can also do that in that fashion as well. If you don't want to see this, okay, click on OK, and yes, the tendon profiles are defined. Click on display. Yes. So this is how we can take the tendon profiles. Now, coming on to the substructure part, most of the engineers can relate to this. It takes a lot of time to create force deformation functions. So we usually receive this in an Excel format from the geotech or the soil department, and then we manually copy paste the PY curves into the software. The effort do not stop here. Then we need to assign the functions to the respective depth along the pile length. So we have to make this process quicker, and is here we simply use the PY curve automated comes. It becomes very handy. So the current practice, as I mentioned, manually copying the PY curve input, then creating the pile nodes based on the geotech data. For example, if you have data at 1 meter, 2 meter, 3 meter, then it is easy. Like we can create it as 1, 2, 3. But sometimes the data will be like 1, 2, 3, 4, 4.2, then 4.6 meters. Then we have at the 5.2 meters, we have the geotech data. So at all these locations, we need the nodes. Okay. And then we have to create the force deformation function, and we have to assign it at those node locations at the springs. At 4.5 meter depth, at that, all those nodes should have the force deformation function corresponding to that depth. Then we'll have to model the pile, connecting all the pile elements. Yeah, pile nodes. So from my interactions with the client, this process takes at least 2 days of manpower unless it's automated using MCT command file. Okay. Now let's check out how the plugin works. So this is how we get the data, soil data from the geotech team. Most of the people, they use GTS NX or LPile, or even yeah. So different softwares will be used to get the PY curve data. So you can see at different depths, Z is equal to 0, 1, 5, 6, 7, 8, 8.4 meter. Now we have 8.52 meter, 9 meter, 10 meter, 10.12 meter. So that means at all these locations we need nodes, and we need the springs at these locations, and the corresponding PY curves should be assigned. Okay, so let's take this example. First, I'm going to copy this data. Okay, then we have the base URL. I'm clicking on connect. Okay, so these are the materials sections. So I have the file, it is not defined yet. So the plugin creates the files as well. We don't have any force deformation functions, nothing. So all you have to do is copy the force deformation function in this fashion for this plugin. If you have any specific format, we can directly create something for reading the data from that format as well. So rigid links, yes. Force deformation functions, properties. So every time previously it should have been done manually, even giving the names one by one, copying the data from Excel. Now it's just one click and the entire thing is done. So something that takes 2, 3 maximum, I would say one hour, it's just a click away now. Now I'm giving a reference node for specifying this is the location of the ground level. Okay, and I'm selecting the first pile nodes. Select. Okay, I'm copying it. Now the give the pile material ID and the pile section ID. Okay, and yes, one and pile section ID which is 5. Pile is section ID 5. Okay, now let's create piles. So the plugin is going to first create the nodes at these locations, and then it is going to create some springs. Then it's going to assign the springs at these, the force deformation functions at these locations. Yeah, so we can see the piles getting generated. We get a message, pile successfully created. Now, if we check on the springs as well, display. So we have the soil springs, and each soil spring is going to have the corresponding force deformation function according to its depth. Now, PAC beam optimization. So the next Excel VBA plugin I would like to showcase is the PAC beam optimization plugin. It's a simple example of design automation and optimization. So before we get into this, let's discuss the changes in numerical model if the design fails. Yes, definitely we start with revising the tendon profile, but for this we can assume by starting to change the adjust the depth of the section, which is very unlikely. But for this example, let's take it like that. Okay. So the first thing is we assume we start by adjusting the depth. We have to update the superstructure and the boundary conditions accordingly to match the depth. Then we revise the tendon profiles to match the new section depth. Then there are many other parameters to consider as well. So once that is done, we repeat this process until the design passes. Okay. So now let's see how the MIDAS API can link our design spreadsheets to Civil NX, automating the entire process with just few lines of codes. Okay, customized to the engineer's requirements. So I've created a very simple basic sheet. Okay, again, the same procedure, linking the sheets with the model. Okay, the mapping key is copied. I'm giving a limiting stress of 3 megapascal, and I'm saying that, okay, this is a load combination. Okay, so I have created some stages as well, and I want the load combination consists some summation. Okay, and I'm saying that the depth increment should be 0.4 meter. So increment or decrement. So if it is less, then it increases the depth. So if it is more, then it decreases the depth. Okay. Now, so section. So this is the section that we have, and the depth is 4.4 meter. It's a unlikely case, I know. Now let's go to the pre-stressing tendons, the profiles. Okay. So yes. So this is the profile. We have two profiles. Okay. Yes. So we want to update everything, all the tendon profiles. So every time when you click on optimize, the the plugin is going to run the analysis. Okay, it's going to extract the data at element number 31 and at part I. Okay, it's going to get the stresses and see if it is more than or less than the limiting stress. So in this case, it is less than the limiting stress. So that is why it is reducing the depth. Okay, so if you look carefully, you can see that the depth is decreasing, the tendon profile is going higher, it's getting adjusted accordingly. Even the substructure is also getting adjusted. Yeah. Okay. So this is how the optimization works. Once the optimization is completed, we can get a simple message that okay, stress at bottom is within limits. Click on OK. Final stress at bottom is 4.61 megapascal, and final depth is also 3.6. Okay. Now, if we go inside and if we check the depth of the section, it's going to be 3.6 meters. So rather than we going inside and changing it, the plugin does it for you. So it's that simple. Even if you check the pre-stressing tendons, the bottom cover is being adjusted. Yep. Now, if you are reducing the limiting stress, also automatically the depth of the sections are going to go higher. So now it's going to go up. Yes. So likewise, if so here I am changing the depth, but in most of the cases we first as an engineer we tend to change the tendon profile to optimize the sections. So this is something that if you have any thumb rules associated, we can directly have use these thumb rules and we can automate the entire process. So rather than changing everything manually, so we can write some simple codes and get this thing done. So here the final depth is 4.4 meter and yeah, so it has been achieved. The substructure nodes, everything is pushed back. Yeah, this is the depth of the section. Yep. Yes. So now as for the question, how much coding one should know to create this many templates or the plugins that we have just discussed, I would say close to nil. If someone wants to do it just using formulas, even that is possible. Now, this is a simple example of PAC composite template, just like the previous one, the box girder one. Okay, so we have created this entire thing using entire template using just formulas. So using formulas, we created the JSON formula. So you can see that if you scroll here, you can see this is a JSON command for setting up the unit. So this is the JSON command again. Using formulas, we have created this JSON out. Okay, even for the cell field. Okay, these are all simple Excel formulas. So in the backend, I've created some backend tools as well. So in the backend sheets, it creates the JSON for, this is for the nodes. Okay, and like for the elements, we have one more backend, the sheet, which is for the section IDs. So again, these section IDs, it's created purely using Excel formulas. Okay, so even using those formulas, we can create these kind of templates. Even though I prefer going with the modeling part, sorry, with the coding part, just by using simple for loop or if else conditions, we can. It's much more efficient for me at least. But even using formulas, we can do it. Okay. Now, when it comes to previously, the case was everyone was using MCT command file, and I've talked to people or engineers like power users who are mostly comfortable with MCT command files. So they use these MCT command files, they create these MCT command files using simple Excel formulas. Okay. So just like that, you can create JSON as well. Okay. Now, if you go to the developer tab and if you check the code, so it's just this much, there is no much code. This code is written only for sending the data. Okay. So other than that, we don't have to use this code. So this part is for entering the mappy key, the base URL, and all those things. And this is for joining the super join function, which joins, different data into one cell because Excel, it already has some data limit for cells. So that's for that, and this is for generating the model, and this function is for just clearing off the things. Okay, so apart from that, we don't need much coding for this. So if you just scroll to this side, you can see these are the JSON comments. We have provided this onto the site so that people will be more comfortable seeing this. Okay, this is what is being sent. So if you click on here, this was the construction stage. So yes, now so coming on to the template, this is very similar to the previous one. I'm saying that, okay, this is the six number of girders and I want the type of section that is type 1 and the diaphragm, we can provide the diaphragms as well. And so here we can even provide the x1, x2 coordinates. So if I am going back, yeah. So going back, you can see x1, x2, y1, y2. We provide these coordinates for creating the bridge. So this plugin is basically we can use it again and again in a single model. So assume you have certain bridge and you want to do some widening. So you can use the same plugin, you create the remaining part. So if you adjust the x1, x2, y1, y2 coordinates, the new bridge is going to get generated at the site. So when you do that, we have to give the start node and the start element node ID and start node ID. Okay. So you can use this spreadsheet again and again. So this is what I meant initially. We can tune it according to our requirement or our specific needs. Okay. So this creates only one single or just one a single span. So like that, using this plugin, you can create multiple spans using the same spreadsheet. All you have to do is change the x1, y2 coordinates, x2 coordinates. Okay. Now, I'll just give you a brief about what all things we have included here. The first one is regarding the girder information. I'm just considering four types of girders. Okay. So this helps us for creating, simplifying the tapered sections and all those things. So this is the girder information type 1, type 2, type 3, type 4. This is again the support girders. We are providing the locations as well, at which locations it should come, and this is the diaphragm information. This is basically D1, D2, D3, D4. It specifies till which location we need the support and from where the tapering starts and where the tapering ends, and the mid section till which portion. So all these things can be defined from here. Okay, these are the material properties. This is the bearing information. According to the bearings will be defined. These are the material properties. Okay, concrete, steel. So you can just select from here which one you require. These are the bridge components. Okay, we can provide different material IDs for this. Then the time dependent material properties, the load cases. Okay, can provide everything. Self weight. Scrolling down, you can find everything, almost everything. Traffic line lanes, even the vehicles. Okay, and at the end tendon properties. Okay, here I have just covered the pre-tensioning for this example, but in future we will be adding up a lot of things. Okay, can provide the loadings as well. Coming here and just click on generate model. You can see that the model is generated. Okay, now again, see, we can create a different model or we can even update the same one as well. So here I have not given any skew angle. So yeah. Now at the top, if you, yeah, it's still sending the data. The time dependent material properties, the tendons. Yeah, now the tendons are also defined. We can even make this process faster by sending all the data in a single go. That is also possible. So yeah, so this is how it looks like. So assume you have certain skew. I'm saying that I have a 15-degree skew. Okay. Now just click on yeah. So before going into that, I'll just give you a brief regarding this model. So the tapered sections, the sections, materials, everything is read directly from the spreadsheets. This is the time dependent material properties. The even the construction stages are defined. So first the girders are here. Now the second part, the third one. Okay. Even the composite section for construction stages are also defined. Okay. We can even provide the age as well. Okay. Now, yeah, this is for that, and now the vehicles, the moving loads, uh, the tendon pre-stressing, all those things are defined. The boundary conditions, I have simplified it and I'm providing it as a spring support at all these locations. Okay. Now, assume I want to provide a 15 degree skew. Okay. Just click on generate model. So automatically the skew is being generated. So previously we cannot do that using the Excel existing wizards. So that is where these kind of templates comes handy. So as I mentioned previously, again, when it comes to coding, it's much easier rather than using the formulas. But if someone is very much inclined towards using the formulas and if they are very good at it, they can definitely create it just like using MCT. So you don't have to, worry about the coding part. It's just when it comes to just sending the data, it's just a single line, and that's not difficult. But if you want to create all the JSON commands using formulas, yes, it is possible. Okay, we'll definitely share this code with you as a reference. Uh, okay, so for people who knows coding, it's not for you guys, but if someone wants to start with the coding part and if they are very good with formulas, they can directly use this one. Okay. Now comes the M connector. It's a MIDAS Excel add-in which helps users to automate report generation, to link design spreadsheets and even export MCT command files to the program. Now, for example, as you know, all the examples that were shown earlier, we need to do a bit of coding using CivilNX API, or even you have to use certain formulas in Excel to create the JSON command. So this M connector can be used without even writing a single line of code. You can simply search for this add-in in Excel. Once installed, you just log in, input the mapping key, and that's it. You can save tables, images in MIDAS Civil and simply call it in Excel with a few clicks. Again, the Excel need not be on the same system as the MIDAS Civil. This makes it easy for monitoring and even extraction required data from workstations anywhere in the world. Let's check out the video. Most of you must have seen this video previously, which, I'm just keeping this as a reference. So we'll just run the analysis, click on connect, go to API settings. So at the top, you can see the M connector. You input your login credentials. So yeah, now you can just copy the API key. Once you paste it, check. So you can see the, when you see the green, that means it is now connected. Okay. In results, for example, if you want to take out the reactions, okay. So rather than copying it every time, you can create a dynamic report image. Okay. Something like this. Click on OK. And yeah, so even this image as well, the in-beam image. Now, using this, we can directly call the tables. You can see the tables has been imported. Likewise, the reactions. Now the image. Okay, scrolling down, you can even bring out the entire element forces. So what we can do if we have a design spreadsheet, so we can create one sheet where you extract all the data. So that's the case in most of the consultancies that I've seen. Most of the engineers, they have a sheet which where you copy the entire MIDAS civil and analysis results. So here you can link your spreadsheets to these tables. Okay. Now, when it comes to report generation, assume you have a sheet already created for a curved bridge. Okay, these are the report that this is the report that you have created. But now you have another bridge which is similar, but everything is straight. Okay, it doesn't have a curvature. It's a new bridge. Okay, now just connect it and click on update all images. So automatically the entire report gets updated as per your new, uh, the new model is concerned. So this is how it looks like. So as I mentioned previously, it's like a one-time thing. You just create it once, and automatically the next time you just have to open the same spreadsheet, okay, and then link the model file and click on update. The report is easily generated. Now, so I would like to talk about the tailor-made Hong Kong plugins. We had discussed this previously in few of our visits to Hong Kong. So altogether, there were three of the cases, three major hurdles that the engineers in Hong Kong mentioned. The one was the wind load, the other one was the thermal loads, and the other one was the load combination. So here I'll be just showing you the brief regarding the wind load and the thermal load plugins. Okay. The first one is the wind. Let's see how to use the plugin. It's directly inside the marketplace for those people who doesn't know about this. So from here it calculates the peak velocity as well. So now plugins, you'll find the wind actions on bridges SDM 2013. It's as per the BD standards. Okay, just click on run. Now the model is generated. Sorry, the plugin UI you can see here. Now the simply two procedures are there. One is the simplified procedure and the other one is the full procedure. So different tables as per the codal provisions is incorporated inside. So we have two locations, the Wanglan Island and the Hong Kong Observatory. So according to that, the peak velocity pressure will be calculated. Okay. Now you can input the other parameters as well. So according to the STM 2013 standard, we have the mean velocity, the peak velocity. According to the height, it changes. So you can provide the height in meters, the horizontal wind load, the degree of exposure, the orographic factors, the climate change. So all those things can be done. And the orographic type is also provided, upwind, downwind. Yes, this is the exposure pattern. Velocity of the pressure, wind pressure will be activated, assigned. Click on OK button to save. Provide a name. Yeah, the force coefficient. So all these things are as per the Hong Kong standards. This is the bridge type in different directions. So we can see all these things. Click on OK. Now just select the elements. Okay, and these are the target elements. Now you have to provide the loading direction in which direction you want to apply. So okay, it's local y plus. You can everything is in there are guide diagrams. You just have to look at the guide diagrams and you will get to know in which direction we have to provide. So the height is also provided, height of the restroom. Click on apply. You can see the wind loads are applied. Now the next one is the thermal action for bridge plugin. So again, as per the Hong Kong standards, we have the temperature uniform and the gradient temperature as well. Just go to marketplace, click on run, and yeah, you can see the types, the basic inputs. The first one is the superstructure type, the type 1, type 2, type 3. So it's a concrete. Yeah, it's a bridge, so we have go for type 3. And then again, all these things are provided in the code. You can see that as well. Thickness. Now the deck surface thickness, how you can provide what are the type of thickness that we have, and the thickness 100 mm, height above sea level. I'm taking it as 50 meters. Yeah, so the uniform and temperature differences. Just select the load case, whichever we are choosing. Select the elements, apply uniform load. So automatically the uniform load is applied as per the standards. Yes. This is for the rise and the other one is for the fall. Okay. Likewise, we have the temperature gradient as well. Section height should be provided. Okay, so this is the standards. You can find all these things in the code as well. The midsection properties, you can see the properties here. So the total section height is 2950. So we have provide that. Yes. So select the load cases, select the elements, click on apply. You can see that the temperature gradient is also applied successfully. Go to the side view, you can see it properly. Yes. So in the marketplace, we'll be providing different plugins as per different regions. So you can, again, as I mentioned, it's sky is the limit for MIDAS API. Just before you just saw the MIDAS tailor-made Hong Kong plugins. So likewise, if you have any other requirements, you can definitely let us know. We will try to create the plugins if it just not need not be something related to MIDAS. You can let us know whatever difficulties, challenges that you're facing with any kind of workflow that is required by the your officials. You can let us know what are the difficulties that you're facing, and we'll come up with some API plugins that you can directly use. You don't have to do the coding part as well. Okay. So in this case, I would like to say that it's a very fast-paced world for bridge engineering, and let's focus as people. Let's focus on better engineering solutions while MIDAS API streamlines all the repetitive tasks. Okay. So if you have any kind of questions, you can ask us now. Okay. Thank you. And yeah, stay tuned for more MIDAS API magic. If you have any queries, you can always get back to us on this mail ID, techsupport@midasit.com. Apart from that, you can even type on the chat box and let us know your Q&A. We can, most of the questions we can take it up. And if there is anything, if time permits, we'll answer everything. And if you are missing out something, we'll definitely get back to you via mail.